Welcome to this explainer, where we're going to calmly guide you through the absolute chaos of a broken deployment using Sentry's observability tools. Look, if you've ever been on call, you know that sound. The pager goes off right after a new release, and your heart rate spikes way faster than a triple espresso. But today, we're going to see how to transform that panic into a predictable, structured investigation. Picture this. You're staring at a massive spike in 500 errors right after a deploy, but you are completely flying blind. Your alerting system is just screaming at you, the charts are spiking off the screen, and customer support is already starting to get tickets. You know something is broken, right? But your standard logs are just giving you this massive wall of text without any real context about what actually changed. So you're left sitting there wondering, okay, which release actually broke the app? What specific files were changed? And honestly, who wrote the code? And this really matters. In modern DevOps, elite engineering teams are targeting a change failure rate, or CFR, of under 2%. When you've got a high CFR, it's a huge red flag. It signals gaps in your release safeguards, leading to system instability and honestly just a ton of wasted engineering hours. If you can't quickly tie production errors back to the exact deployment that caused them, hitting that elite metric? Yeah, nearly impossible. Well, let's dive into how configuring Sentry release tracking prevents this exact nightmare. Sentry doesn't just catch exceptions. It acts like a black box flight recorder for your application. By telling Sentry exactly when a new version of your code goes live, you anchor all of your production telemetry, errors, traces, performance metrics, the whole shebang, directly to that specific release. And setting this up is actually pretty straightforward using the Sentry CLI or a CI/CD integration like the Sentry Release GitHub Action. First up, you integrate your source code provider, GitHub, GitLab, whatever you're using. Next, you set up code mapping, so Sentry knows exactly how the file paths in your compiled stack traces relate to the paths in your repo. And finally, you just drop the officially supported Git Sentry Action Release version 3 straight into your deployment pipeline. By simply passing your secure auth token, your organization slug, and your project name into the pipeline as environment variables, Sentry essentially takes over. It automatically creates a release object, injects debug IDs into your source files, handles uploading all those source maps, and associates the newly deployed commits. You literally don't have to manually update a thing. The pipeline does all the heavy lifting every single time you merge. Navigating the releases dashboard. Let's move on and see how this deploy command center builds a comprehensive view of your application's health inside Sentry. Once your pipeline is notifying Sentry of every single deploy, this dashboard becomes your absolute central hub for deployment stability. Now, what's fascinating here is how clearly these metrics contrast a healthy deployment with a failing one. Just look at version 2.4.0, it's sitting at a beautiful 99.9% crash-free rate with a totally negligible failure rate. But then look at version 2.4.1. The failure rate has completely shot up to almost 18%. Because Sentry is constantly comparing percentage-based metrics of the current release to your historical averages, you can spot these anomalies instantly, like way before your users start getting frustrated and churning. You can also immediately spot adoption curves, letting you know exactly what percentage of your users are currently exposed to this new, problematic version. If you're doing a canary release or some kind of phase rollout, this is absolutely critical. Seeing that 75% of your sessions have already adopted version 2.4.1, that tells you the blast radius is expanding rapidly, and you need to act, like, right now. Okay, so here's where it gets really good. The crucial feature here is called suspect commits, which uses git blame to map an error directly to the developer who authored the code. Here's how it works under the hood. When an error fires, Sentry looks at the in-app frames of the stack trace. It checks the blame information for those exact files and line numbers. If a commit was made to those lines within the last year, boom, Sentry flags it as a suspect commit. It is literally the definitive smoking gun. It takes you straight to the root cause without hours of manual log digging. Instead of assembling a giant panic war room and having 5 engineers grep through different logging tools, Sentry points directly to the pull request that introduced the failure. It even surfaces the author as a suggested assigning to fix it. How cool is that? Resolving the v2.41 scenario. Let's apply all this to our earlier scenario. You've got this massive influx of 500 errors appearing right after a deploy. The alert goes off in your team's Slack channel. But this time, because you have release tracking configured, that alert isn't just some generic timeout error. It is explicitly tagged with the new release version. And notice the stark contrast here. This perfectly illustrates debugging in the dark versus investigating with trace-connected metrics. When you're just looking at raw error tracking, you know that something broke. But when you add release and commit tracking into the mix, you know exactly why it broke and who has the context to fix it. Instead of just an isolated stack trace, Sentry is showing you the exact GitHub commit, the author to assign the issue to, and the specific lines affected. Look, debugging in the dark means a horribly high mean time to resolution, or MTTR, because you're manually trying to correlate a spike in your APM tool with the timestamps of recent CI/CD pipeline runs. Debugging with Sentry means you get inline source context right on the issue details page. You can literally click Open this line in GitHub and jump straight from the stack trace right into your repo. So, with calm confidence, you identify that the 500 errors stem from a backend regression introduced in commit ABC123. This lets you instantly roll back or just push a hotfix. Say the commit introduced a nasty N+1 database query that totally exhausted your connection pool. Because Sentry connects the metrics to the trace and the trace directly to the release, your whole investigation phase just dropped from hours down to literally minutes. So with your incident successfully resolved and everyone breathing a sigh of relief, consider this. How much faster could your team ship, and how much lower would your change failure rate drop if you never had to play detective in the dark again? Food for thought. Thanks for joining me for this explainer, and happy coding.